All right, so based on these following reactions, write a half reaction table and label the strongest oxidizing agent and strongest reducing agent. So the very most important components that you will learn in Chemistry 30 is Leo, Ra, and GrOA. So Leo Ra is losing electrons, oxidation, reducing agent, and GrOA is gaining electrons, reduction, oxidizing agent. So before we can build the reaction table, first we need to identify which one of these are. So when we go from CD to CD2 positive, we have to identify which is the reducing agent and which is the oxidizing agent. So here we have cadmium going from to its elemental form, neutral form, to its ionic form, 2 positive. So it goes from 0 to 2 positive, and that is a loss in electrons. So this is our reducing agent. And here we have our hydrogen ions going to its hydrogen gas. So we go from a positive charge to 0. That's a gaining electrons. So this is our oxidizing agent. So this is GrOA, oxidizing agent. Now based on this information, now we're going to use the spontaneity rule to determine which goes above and which is on the bottom, so we can start our table. Okay, so if this reaction is spontaneous, we know that our oxidizing agent has to be in a higher position on our reduction half reaction tables than our reducing agents, and the opposite is true. And if this reaction is non-spontaneous, then that means that our reducing agent will have a higher position than our oxidizing agent. So in this case, our reaction is spontaneous. So therefore, our 2 hydrogen ions plus 2 electrons gets us to H2 gas. So our hydrogen ion, our hydrogen oxidizing agent, will have a higher position than our cadmium reducing agent. Okay, now let's move on to the next reaction. So here we have a hydrogen ion in this first and second reaction. So now this reaction is not spontaneous, but what I like to do is I like to pretend that this reaction goes through. Even though it doesn't, this will help us in identifying our oxidizing agent and our reducing agent. So if we pretend that we go from H2 positive, so therefore its ion form to its elemental form, we go from a positive charge to 0. So this is our oxidizing agent. And then mercury. Now mercury has 2 different charges, correct? But we're going to use its most common ion, or in this case, we're just going to use it based on whatever hydrogen, how many charge the hydrogen has. So in this case, there's 2 positive hydrogen. I'm just going to assume that mercury is going to go from its elemental form to its ionic form as 2 positive. So in this case, mercury goes from 0 to 2 positive charge, so that is losing electrons. This is our reducing agent. Now we have to pay attention to the reaction. Now, the reaction is non-spontaneous, which means that when the reaction is non-spontaneous, the reducing agent has to have a higher position than the oxidizing agent. So therefore, our reducing agent will be above our oxidizing agent, which means that our mercury will be above our hydrogen ion. So liquid. Okay, now let's go to the next reaction. So our next reaction, we have beryllium and cadmium. This reaction is spontaneous, so let's identify our oxidizing and reducing agent. So when beryllium goes from its neutral form to its ionic form, we can see that it goes from 0 to a 2 positive charge. It is losing electrons, so this is our reducing agent. And cadmium goes from a 2 positive to a 0 to a neutral elemental charge. So therefore, we have 2 positive to 0. That is gaining electrons. This is our oxidizing agent. So using our spontaneity rule, this reaction is spontaneous. So therefore, we know that cadmium will have a higher position as an oxidizing agent than the beryllium. So the beryllium will be below this. All right. Then for our last reaction. So again, we're going to do the same thing like we did for the second reaction here. We have cadmium 2 positive plus beryllium, and if we pretend that the reaction is spontaneous, even though it's not, we can see that calcium goes from 2 positive we'll go from its 2 positive ionic form to its neutral form. So therefore we go from 2 positive to 0. This gains electrons. So this is our oxidizing agent. And beryllium, if we pretend like the reaction is spontaneous, then beryllium will go from its ionic form to its goes from its elemental form to its ionic form. So it's going to go from 0 to 2 positive charge. And so this is losing electrons. This will be our reducing agent. Now, our reaction is non-spontaneous, so which means that our reaction is non-spontaneous, so which means that our reducing agent will have a greater position on the table than our oxidizing agent. So because we identified that beryllium as our reducing agent, calcium will be below beryllium. If we draw our table, so this is our strongest oxidizing agent, this is our weakest oxidizing agent, and this is our weakest reducing agent, this is our strongest reducing agent. And so here's our table. Now to check, we can check if these chemicals are in the right position if we use our spontaneity rule. So going back to our first reaction here is spontaneous. So our hydrogen ion as an oxidizing agent must have a higher position than our cadmium as a reducing agent, and that's the case. All right, second reaction. So our hydrogen ions, again, we identified as our oxidizing agent. So therefore, but because this reaction is not spontaneous, our reducing agent, mercury, will be above our hydrogen. So in this case, our mercury reducing agent will be above our hydrogen oxidizing agent. Next, we have beryllium and cadmium. So since we know that cadmium is our oxidizing agent and this reaction is spontaneous, then our cadmium will be above our beryllium. So our cadmium 2 positive oxidizing agent will be above our beryllium reducing agent. And finally, we have another non-spontaneous reaction. Oh, sorry, pardon me. I must have made a mistake here. Sorry. Our beryllium here, our cadmium oxidizing agent must be above our beryllium. So, sorry if I made a mistake there. All right, then our final reaction here, we have C2 positive and beryllium. If we check to make sure, since beryllium is our reducing agent for this one, we know that our reducing agent has to be above our oxidizing agent because it's non-spontaneous. So our beryllium element reducing agent must be above our calcium oxidizing agent. So that concludes the video. Hopefully this has helped you.